Hello everyone, welcome back to my channel InfoSec Lab, and today we are going to continue another vulnerabilities on TryHackMe's web app pen testing, and it's going to be ORM injection. Now, don't worry if you don't know what it is, because in this room I'm going through what ORM is, how it is used in modern web applications, and how to exploit the vulnerabilities in web applications that use ORM. Introduction. With advancement in cybersecurity, many developers have adopted Object Relational Mapping, which is ORM, to mitigate SQL injection attacks. While ORM is intended to simplify database interactions and improve security, the threat of injection attacks is still not over. ORM injection occurs when attackers exploit vulnerabilities within the ORM frameworks, allowing them to execute arbitrary queries. We'll explore advanced ORM injection techniques in this room, providing an in-depth understanding of sophisticated attack vectors and effective mitigation strategies. By the end of this room, you'll get a comprehensive understanding of various ORM injection methods, which will help you identify and exploit these vulnerabilities to safeguard web applications. The learning objectives is to understand ORM, identify injection, identify some weak implementations and vulnerable implementations. Some learning prerequisites. A basic understanding of the following topics is recommended. SQL injection and OAuth Sub 10. Pretty much that's it. Alright, let's dive into the topic. What is ORM? ORM is a programming technique that facilitates data conversion between incompatible systems using object-oriented programming languages. It allows developers to interact with database using programming language native syntax, making data manipulation more intuitive and reducing the need for extensive SQL queries. ORM is particularly beneficial when complex data interactions are required, as it simplifies database access and promotes code reusability. The purpose of ORM is ORM serves as a bridge between the object-oriented programming model and the relational database model. The primary purpose of an ORM is to abstract the database layer, allowing developers to work with the objects rather than the tables and rows. This abstraction layer helps in reducing the boilerplate code. ORM reduces the need for repetitive code by automatically generating SQL queries based on the object operations, increasing productivity. Developers can focus on the business logic without worrying about database interactions, ensure consistency. ORM frameworks consistently handle database operations, reducing the risk of errors, enhancing maintainability. Changes to database schema are easier to manage, as they can be reflected in the object model without extensive code modifications. There are some common ORM frameworks being used in applications depending on the programming languages that are used. Doctrine is used for PHP. Doctrine is a powerful and flexible ORM framework for PHP. It is particularly popular in the Symfony framework, but can be used independently. Doctrine provides a comprehensive set of tools for database interactions, including a query builder, schema management, and an object-oriented query language. Its ability to map complex object structures to database schemas make it favorable among PHP developers. Hibernate. Hibernate is a robust and mature ORM framework for Java applications. It simplifies mapping of the Java classes to database tables and provides powerful data retrieval and manipulation capabilities through its Hibernate Query Language, or HQL. Hibernate supports various database management systems, as it's known for its performance optimization features, such as caching and lazy loading. SQLAlchemy for Python. SQLAlchemy is a versatile and powerful ORM for Python. First, a SQL toolkit and an ORM system that allows developers to use raw SQL when needed while still providing the benefits of an ORM. SQLAlchemy's flexibility and modular architecture make it suitable for a wide range of applications, from small scripts to large-scale enterprise systems. Entity Frameworks is Microsoft's ORM framework for .NET applications. It enables developers to work with relational data using domain-specific objects, eliminating the need for most data access code that developers typically need to write. Entity Framework supports a variety of database providers and integrates seamlessly with other .NET technologies. Active Records. Active Records is a default ORM for Ruby on Rails applications. It follows the Active Record design pattern, which means that each table in database corresponds to a class, and each row in the table corresponds to an instance of that class. Active Record simplifies database interactions by providing a rich set of methods for querying and manipulating data. Answer the question, what is the default ORM for Ruby on Rails applications? That's going to be Active Record. Which of the following is not a feature of ORM? Reducing boilerplate code, increasing productivity, increasing attack surface due to direct interface with the database, and ensuring consistency. It's going to be C. That's not a feature of ORM. So how does ORM work? Mapping between objects in code and database table. ORM is a technique that simplifies data interactions in an application by mapping objects in code to database tables. In PHP, this process involves defining classes that represent database tables and their relationships. Each class property corresponds to a column in a table, and each class instance represents a row. For instance, using Laravel Eloquent ORM, you might define a model class like this. In this example, the user class maps to the users table in the database, with properties corresponding to the columns. Eloquent ORM handles the translations between these object representations and the underlying SQL queries, allowing developers to manipulate database records using object-oriented syntax. So we have the class user right here. It corresponds, or it maps to the users table in the database. And these are going to be the properties of that table, which is name, email, and the password. Some common ORM operations: create, read, update, and delete. ORM frameworks streamline common database operations, often referred as CRUD operations. Create a new records in database involves instantiating a new model object, setting its properties, and saving it to the database. So this code snippet creates a new user and saves it to the database. The save method prepares the entity for the insertion and executes the SQL insert statement to add a new record to the users table. The bcrypt function is used to securely hash the password before saving it. So now we create a new user, and these are the properties of this new object, which is admin. The name is admin, email is admin@example.com, and the password is going to be whatever the password is, and it's going to be hashed using the bcrypt algorithm. Reading records from the database involves retrieving data using various elegant methods. This is a code for retrieving data. Depending on the requirements, we're going to use different syntax to retrieve the data. So this code demonstrates different ways to retrieve records from the database. The function find1 retrieves the user with ID 1 by executing a select SQL statement. The function all retrieves all the user in the executing and select everything from users table. The class where email admin example.com get retrieves the user with a specified email by executing select everything from users where email is equal to admin@example.com. Similar to the create and read operations, the update and delete functionalities allow a straightforward approach using Laravel Eloquent ORM. For updates, you retrieve the existing record, modify its property, and save the changes. For deletions, you retrieve the record and call the delete method to remove it from the database. Eloquent handles the preparations and execution of corresponding SQL statements, making database operations simple and intuitive. So now we're going to compare SQL injection versus ORM injection. SQL injection and ORM injection are both techniques used to exploit vulnerabilities in database interactions, but they target different levels of stack. For SQL injection, it targets the raw SQL queries, allowing attackers to manipulate SQL statement directly. This is typically achieved by injecting malicious input into those queries. The injection part of the following query, or 1 equals 1, always evaluates to true. allowing attackers to bypass authentication. ORM Injection. ORM Injection targets the ORM framework, exploiting how it constructs queries from the object operations. Attackers manipulate the ORM's method and properties to influence the resulting SQL queries, which is something like this. So the key differences in exploitation technique. From SQL injection, we target the raw SQL queries. For ORM injection, we target the ORM framework's queries construction. When it comes to complexity, SQL injection is more straightforward as it manipulates the raw SQL queries. Versus ORM injection, it requires understanding of the ORM internals and methods. So you're gonna have to understand what framework is used, what methods are used within the applications. A little bit more complicated. Detection. SQL injection is easier to detect with traditional web application firewalls and query logs, whereas ORM injection is a little bit harder to detect as the payloads are within the ORM methods, and it doesn't show the right way. Mitigation. The use of prepare statement, parameterized queries, input validations are the main methods for SQL injection prevention. For ORM injection prevention, proper ORM configuration, application level input validation, ORM features enforcing query safety. Those are the mitigation measures for ORM injections. Configuring the environment. Since we're using Laravel in this project, we'll briefly explain how to configure Elegant ORM. Elegant ORM is a default ORM included in Laravel, which provides a beautiful, simple active record implementations for working with database. First, we need to install Laravel using Composer. Now, just keep in mind that this is just for reading purposes only. You don't have to follow this step. Open the terminal and run the command Composer create projects, and with the following flags. And TryHackMe project is going to be the name of the project. Okay. Configuring the database credentials. Next, we need to configure our database credentials. Laravel uses the .env file to store environment variables, including database credentials. So we're going to create another file called .env, and here we're going to store our database credentials information like the host, the database port, database name, username, and passwords, everything. Setting up migrations. Migrations are like version control for your database, allowing you to easily modify and share database schema. Laravel's migration system is essential part for the framework and simplifies the management of database changes. To create a migration, we can use the artisan command that comes with Laravel. You can run the command php artisan make migration and then create user tables, and with the flag create users to generate a migration of the table users. This command generates a migration file in the database migration directory. The migration file contains method to define structure of the users table, and it looks like this. The above code, the up method defines the structure of the users table, which is this one. It includes a column for ID, name, email, password, and timestamps. Name, email, password, and timestamp. Conversely, the down method drops users table if the migration is rollback. Okay, straightforward. After defining the migration, run the command php artisan migrate to apply the migration and create a new users table in the database. This command will execute the up method in the migration file and create a users table with the specified columns in your database. In the context of ORM, migrations simplify the process of mapping database tables to applications models. They enable developers to focus on writing clean, maintainable code while ensuring that the underlying database scheme supports the application's data requirements. However, from a red team perspective, improperly configured migrations and weak implementations can lead to vulnerabilities like ORM injection. Hackers often exploit these weaknesses to manipulate database queries and gain unauthorized access to sensitive data. Therefore, it is crucial to use migrations effectively to enforce strong, secure database schema designs and ensure robust ORM configurations to prevent such security flaws. So as the method using a Laravel code snippet to define the structure of the user table is going to be up. So what's the file name used to store database credentials in Laravel? That's going to be env. Now keep in mind that it's not only in PHP and Laravel, it's also in Python or Node.js applications. We also use .env file to store credentials or any import API keys or secrets. Identifying ORM injection vulnerabilities involves examining how user inputs are handled within the ORM queries. Oh, I'm going to start the machine first. Identify ORM injection vulnerabilities involve examining how user inputs are handled within the ORM queries. These vulnerabilities typically arise when user inputs are directly embedded into the ORM query methods without proper sanitizations or validation. Indicators of potential ORM injection issues include the use of dynamic queries that concatenate user inputs, raw query execution methods, and insufficient use of parameterized queries. Techniques for testing ORM injection: manual code review. A thorough source code inspections can reveal raw query methods, such as the where raw in Laravel, that incorporate user inputs directly. Look for concatenated strings or unescaped input for ORM methods, which indicate the injection points. Automated scanning. Use security scanning tools that are designed to detect ORM injection vulnerabilities. These tools analyze the code base to identify patterns that could lead to injection, such as dynamic query construction or improper input handling. Input validation testing. Perform manual testing by injecting payloads into application inputs to see if they affect the underlying ORM query. For example, injecting SQL control characters or keywords to determine whether they alter the execution of the query. Error-based testing. Enter deliberately incorrect or malformed data to trigger errors. Detailed error messages can provide insight into the structure of the underlying queries and indicate the potential vulnerabilities. Okay, so these are going to be a few things that we need to look at. In Laravel, so we look for these methods. In Ruby on Rails applications, these are going to be the methods we look at. And the same for Django, which is Python. Spring is for Java applications, and Node.js for Node.js applications. Now that we know how to identify ORM injection vulnerabilities, let's visit the website. Here, you'll see that the site prompts you for input. To determine which framework is being used, we can employ various techniques, such as inspecting the cookies, reading the source code, and analyzing the HTTP headers. Verifying the cookies. Examine the cookies set by the applications. Frameworks often use unique naming conventions or formats for their sections cookie, which can provide clues about underlying technology. So in this case, it's a Laravel session, so it's PHP for sure. Review the source code. Look through the HTML source code for comments, meta tags, or any embedded scripts that might reveal the framework-specific signatures. So if you take a look at the page source, you're going to see that a comment in the page source is the application is using Laravel Framework 5.0. Oh, no, not 5.0, sorry, 5.x version. Analyzing the HTTP headers. HTTP headers can sometimes contain information about the server and the framework. Tools like Burp Suite or Browser Developer Tool can be used to inspect these headers. URL structure. The structure of URLs can give hints about the framework. For instance, certain routing patterns are unique to specific frameworks. Login and error pages, authentication pages, and error messages can sometimes reveal the framework. Some frameworks have distinctive error pages or login form structures. So when we land on the application, there are several places to look for the framework or to learn about the technologies that the application uses. So in this case, let's just go to the page source, view page source. Over here, you see in the comment, it's using the Laravel framework. So that's one way to look at it. But again, information in this page source is not very conclusive. So we have to dig further to confirm our findings. And the second place we should take a look at is the cookie sections. Go to the storage tab, and you're going to see a bunch of cookies set right here. There are two things that you can pay attention to. You can see right here, Laravel section, indicating that the application is using Laravel and PHP, sorry. So that's another place we can take a look at to learn about the technology stack. Another way is to go to the network tab and try to enter something. Okay, you click on the get request. You're gonna see several requests, right? Click on this one. And over here, you can investigate the headers. You see, this is the get request header. What we're interested is in the response headers, which contains information about the servers, like the cookie sections right here, the XSRF token, and the Laravel sections. So this is another place to find out about the cookies values and the information about the servers that we're testing on. So yeah, these are the common places that we should take a look at when it comes to reconnaissance. Now that we have identified the applications using Laravel by inspecting the cookies, we can dig deeper by supplying malicious input to explore its behaviors. Specifically, we'll put 1 equals to see how the applications handle this data and confirm the URL ORM use. So when we're on this page, we prompted to provide input. We enter this one to the vulnerable input field to submit the form and determine how the application processes this input. This particular input is designed to disrupt the query structure and reveal the underlying issues on how the application constructs its queries. So let's try that. You may notice that the payload is similar to SQL injection. That might be a little bit confusing at first, but eventually when you get used to it, you'll know what payload to use. So over here we have SQL state 42,000, syntax error or access violation. You have an error in your SQL syntax. Check the menu that corresponds to your MariaDB servers. So here, based on the errors, we know that it's using MariaDB. And then it also provides the SQL statement that is used. Select everything from admins where email SQL wants. We clearly see that this is an error, right? So by intentionally providing a mail form data into the input field, we learn a lot more about the system and the database servers that the application is using. Upon submitting this input, we need to closely observe the application's response. If the application returns an error message, it can provide valuable insights into the query's construction process. So this is the one that we mentioned earlier, indicates that the input has been improperly handled and concatenated into the SQL query, resulting in syntax error, which we learned about that earlier. The output shows that it uses Laravel's elegant ORM as the error message and the query patterns. As the error messages and the query patterns are characteristic of elegance for red teamers, identifying ORM injection vulnerabilities is critical to assessing an application security posture. ORM injection can be exploited if the user's input are not properly sanitized and validated, leading to unauthorized access or manipulation on database queries. Red teamers can uncover these vulnerabilities by employing techniques such as manual code review, automated scanning, and rigorous input validation testing. Using secure coding practices like parameterized queries and robust input validation is essential to mitigating the risk associated with ORM injection. Regular code reviews and the use of security tools can help developers identify and fix these issues. So what's the path document root variable? Okay, let's take a look at it. Document root variable, this is the root path. Submit. What is the ORM library for Spring Framework? It's Hibernate. Once you have reviewed the cookies to identify ORM, what's the cookie's name that is responsible for maintaining a section in the attached application is Laravel section. ORM injection with implementation. In this task, we'll explore how an attacker can exploit ORM vulnerabilities when the ORM is quickly implemented. Okay, we're going to visit the same URL where we have two input fields. Let's take a closer look at the source code used by the developer. So this is the code for the vulnerable email input, which is this one, this field right here. So what does this function do? The search blind vulnerable function is designed to retrieve user records based on the email parameter provided by the user. It's a detail of the breakdown function. Retrieve the input. The function captures the email parameter from HTTP request. This is done by using input method of request object. Okay. Construct a query. The function that constructs a raw SQL query using Laravel's where method, which directly incorporates the email value into the SQL statement. Right here, execute the query. This query is executed, storing the result in the user's variable, which is this line right here. Finally, the function returns a view. If the user's array is not empty, it passes the user data to the view. Otherwise, it passes user not found message. The critical issue in this function lies in the direct use of where, which is this line right here. This method of query construction is vulnerable to injection attacks because it does not sanitize the user input. An attacker can exploit this vulnerability by manipulating email parameter. If attacker input this one, the payload, the resulting query should be like this, something like this. This query will always return all user records because the condition 1 equals 1 perpetually is true. Detail exploitation. Input malicious value. The attacker visits the input field on the website and enters the corrupted input, like something like this one. The attacker now has access to potentially sensitive information about all users in the database. Okay, so we have two users in the users table, John Doe and Chen Doe. Here's a secure implementation. So everything is going to be the same except that this one constructing the query securely. Instead of using the where raw method or function, the secure version of this is going to the where function. This method automatically escapes the input, thus preventing SQL injection. The where method constructs a parameterized query behind the scenes, ensuring that user input is not directly included in the SQL statement. And pretty much the rest is the same. If the user is not empty, it returns the user data. Otherwise, it will return a message, user not found. Let's try this one. Search. Because there's no user with this email address, we're going to get a message, user not found. Hence the flag. Oh, not this one. TryHackMe secure with a one. What? Oh, it's 001. What is the email associated with a Chen Doe? TryHackMe.com. And what is the name of the variable allocate method that use where raw? Okay, so why is this secure? Parameterized queries. Parameterized queries ensure that the input values are treated as data only, not executable code. This prevents any injected SQL from being executed. Automatic escaping. Allo can automatically escape the input values, negating any special characters that could be used for SQL injection. Consistent query logic. By using the allocate methods like where, the query logic remains consistent and clear, making it easier to maintain and audit for security. The use of where in the function search blind variable demonstrates the weak implementations of ORM, making the application highly susceptible to injection attacks. By understanding how user inputs are directly incorporated into SQL queries, attackers can craft inputs to manipulate the query logic. This highlights the importance of using parameterized queries and proper input validation to secure web applications against such exploit. Okay, let's talk about vulnerable implementation. Why secure coding practices are essential. It is important to recognize how a developer might inadvertently implement a vulnerable version of ORM, creating avenues for exploitation. Vulnerable implementations can occur when developers use outdated or misconfigured ORM libraries that contain inherent security flaws. These flaws can be exploited by attackers to manipulate database queries and gain unauthorized access control. Such vulnerabilities may stem from issues like improper handling of query parameters or inadequate protection against injection attacks within the ORM framework itself. Developers must ensure they are using up-to-date and secure versions of ORM libraries to avoid introducing exploitable vulnerabilities in their applications. Practical example. One example is the Laravel Query Builder package, which had a significant security flaw in the version prior to 1.17.1. This vulnerability allowed SQL injection through unsanitized query parameters. The vulnerability was identified in how the package handled sorting parameters directly from user input without proper validations. We have used the SPAT Query Builder in this example, which also uses Laravel Query Builder internally to make queries. So for the demonstration purposes, we have to visit this URL. This endpoint allows getting the top user sorted by name column via the source parameter. Sort by name. So Alice, Bob. Okay. Let's take a look at it. The Laravel equivalent translations of query is select everything from users, order by name, in an ascending order, limit by 2. So basically this endpoint only retrieving the top 2 users in the list. So now let's try to inject the attempt. If we try injecting the name parameter with the name, we'll see that the app returns an error and that it couldn't find any column name. So with a single quotation mark, we see the same errors. Oh no. We see different errors. SQL 42 S22 column not found. Column name is not found in order. Here, the same thing. When we try to trigger an error message, it provides us more information about the database used. In this case, unknown column name, and then we also learn about the SQL statement. Our objective here is to manipulate the query to retrieve complete data from the users table instead of being restricted to a limited number of rows. However, injecting a sort parameter in this context is not straightforward and merely concatenating with a select query and using routine injection methods. The challenge lies in the effectively breaking out order by manipulating the query execution. To achieve this, we can utilize a special function, the right arrow operator, which serves as an alias for JSON extract function in MySQL. This operator allows us to navigate JSON data and extract specific values. By using this operator, in conjunction with the payload, we can break out the order by clause. This payload, right arrow, double quotation mark, %27, effectively terminates the JSON extraction bypasses the limitations imposed by the initial query and allows us to append additional SQL commands. We're going to prepare the final payload. The initial query is going to be something like this. Set everything from user. Let me breaking the queries by injecting the payload, this one. We can cause a query to break and thus creating an opportunity to insert our own SQL. Crafting the payload to exploit this vulnerability, we craft the payload to break out of the string and inject our SQL. The payload would be something like this, name, and then this one, and then SQL injection query. Within a parameter value, the right arrow is parsed by Laravel and replaced with JSON MySQL injection. On the other hand, this part of the payload closes the previous string and conditions. SQL injection query allows an attacker to write his own query. The character pound comments out the rest of the query to prevent syntax error. Final results. The payload for getting additional rows for the database would look something like this, while the generated level in an SQL database would look something like this. So let's try that. So let's try to decode it. This is the payload, the final URL with the payload, and this is the resulting SQL query. So what is this? We have this one. Put up right here, we have this one. URL decode. Okay, so this is the raw input or the raw payload. This is the URL encoded version. The above query would bypass the limit capability and fetch 10 rows from the user data. So let's try that. And we got 1, 2, 3, 4. We'll have 4. We'll have 5 users. 5. Then TryHackMe 101. Okay, best practices. Now that we understand the threat surface of ORM injection, preventing these vulnerabilities requires implementing robust security measures and continuously monitoring potential weaknesses. The following sections outline the best practices for securing user inputs and leveraging automation techniques to effectively identify and mitigate injection vulnerabilities. Input validation. Always validate user inputs on both client side and server side. Ensure that data conforms to be of expected format, type, and length. Use regular expressions and built-in validation functions to enforce strong input validation rules. Parameterized queries. Use parameterized queries, which is known as the prepare statements, to interact with the database. Avoid concatenating user input directly into SQL queries. ORM usage. Utilize ORM built-in tools to interact with the database. ORMs abstract SQL queries and help prevent SQL injection by handling user input securely. Ensure that the ORM is configured correctly and any custom SQL queries are parameterized. escaping, and sanitization. Escape user inputs to remove any special characters used for injection attacks. Sanitize inputs to remove potentially harmful data before processing or storing it. Allow list input. Implement an allow list approach for input validation. Only allow specific expected values and reject everything else. This method is more secure than blocklisting known bad values, which can be incomplete. Application in popular frameworks. We'll explore essential practices for safeguarding against ORM injection in widely used ORM frameworks. ORM tools like Doctrine, SQLAlchemy, Hibernate, and entity frameworks provide powerful abstractions for database interactions. However, to prevent SQL injection vulnerabilities, it's crucial to employ secure coded practices such as parameterized queries, name parameters, and ORM-specific techniques. So let's dive into these practices. For Doctrine PHP, we use the prepare statements with the parameterized queries, like this. For SQLAlchemy, we use parameterized queries, which automatically handle escape and parameter binding. Okay. Hibernate using the name parameter Hibernate. Use name parameters with Hibernate's query API to ensure inputs are adequately bound to an escape. String eq form user where username equals user. Query. Entity framework. Employ parameterized queries in entity framework to secure database interactions and mitigate the risk of SQL injection. User equal context users for so these are the built-in methods of the frameworks. So depending on the applications that you're testing, you're gonna have to learn about the frameworks and how to use these methods. These practices underscore the importance of adopting secure coding practices tailored to each ORM framework, ensuring robust protection against ORM injection vulnerabilities. So is it a good practice to write a raw SQL query in ORM? No, never ever. Which sides of the input validation should be carried out? It should be both client and server. Key conclusion. Throughout our exploration of ORM injection, we begin by establishing a solid understanding of what ORM entails and its fundamental role in modern web application. We explore how it's working, understanding how ORM abstract database interactions into object-oriented paradigms, enhancing developers' productivities and code maintainability. Moving forward, we shift the focus to the perspective of a penetration tester, learning how to identify potential injection vulnerabilities, specifically with Laravel, a widely used PHP framework. With this foundational knowledge, we examine the exploitations of poorly implemented ORM systems. We uncover how vulnerabilities in ORM configurations can lead to injection attacks, allowing malicious actors to manipulate database queries and potentially gain unauthorized access to sensitive information. To conclude this, we highlighted essential security practices within popular frameworks. These practices include rigorous input validations, proper use of parameterized queries, or prepare statement to mitigate injection risk, and leverage ORM frameworks with built-in security features. By adopting these practices, developers can safeguard their applications against ORM injection vulnerabilities, ensuring a well-protected and secure web application. And that's it for the room today. If you have any questions or if there's any confusion during the walkthrough, please feel free to reach out to me or put a comment below. I'll be happy to answer your question. Thank you very much, and I'll see you next time. Bye-bye.